Heat loss calculator. One of the very best and most popular apps, and it's been downloaded right across Europe and America, Australia, etc. because it actually works very well. But it has two meanings. First of all, for people who live in the house, it tells them how well or badly that room, house, is insulated. And as we all know, of the 30 countries in the EU, the worst built houses is, guess? Yeah. Yes, the UK. We are bottom. We are number 30. Or in other words, we're number 1 for having the worst built properties. They're absolute rubbish. Ever since the war, they've been rubbish compared to what they get installed. We don't get cellars. We don't get playrooms and offices in the lofts. We don't get nothing. The other day, no, a month ago or so, I was in a new terrace build and I sneezed. And both the neighbours said, bless you. There you are. That's us. It's a shame really, but no government seems to bother about our housing stock and making it as good as those across the channel. So that's why this heat loss calculator is important to you when you live in a house. To an installer, heat loss means how large a radiator has to be fitted in that particular room to take it to a temperature of 20, sometimes 22, but the 20 is the general figure for a lounge for people to sit down and watch TV. Obviously, we're all a little bit different, and some people may say calculate to 22 or even 24 degrees, which is going to be expensive, obviously. The 20 degrees we calculate from the heating flow to the heating return on the boiler, and there has to be a 20-degree rise or difference. So therefore, we move that over to the heat loss calculator. Now, there's two ways we can do this. You can either get a piece of paper. Here's an example that I've done for this unit. I've gone through all the radiators and I've looked at a basic standard price list from a merchant or from a manufacturer, and I've looked at the height, the length, whether it's a single panel radiator or double convector, which is known as a K2 or a type 22. Anyway, I've written it down, and here's a picture of the corner so I can show the engineers who come here. They all have to do this to calculate all of the radiator sizes and input that into the boiler. Because we know on Combi boilers, a lot of them, in fact most of them, can be range rated. When it comes out the box and it's on the floor, they are all set at 24 kilowatts of radiator load. But as you can see here, I've only got 12. So therefore, my efficiency is 50%. And if I did nothing, my gas bill would be twice the height or twice the amount. And that happens all over the UK because installers don't really bother doing this. Very few, all the good ones, hopefully the factory trained ones, they will actually do this. And they'll go through the same as I suggest to you. Get a long piece of paper, start from the hall as always, height, length, what type? Dining room, kitchen, bedroom 1, 2, 3, 4, whatever, utility room, downstairs loo, all of the radiators, work out in watts or kilowatts, the whole total. And then that figure goes into the boiler output. The problem you need to remember is that if your boiler is up in the loft, you can't do that. You've got to add at least 3 or 4 or even 5 kilowatts on top of your radiators, because going from the loft down to that furthest large radiator in the hall or lounge is going to lose an awful lot of temperature. Even after lagging, it's still going to lose a lot of temperature, so you have to compensate for that. A normal 3-bedroom semi is around 14-15 kilowatts. If you live in a park home or a 2-bedroom bungalow, you might be nearer 9. So having a boiler that's outputting 3 times, almost 3 times the amount, is a complete waste of gas, and you're paying for that. So get a factory trained engineer or somebody who's been on my course, Mr. Combi Training, get them to have a look if your particular Combi boiler can be downrated on the heating side. The new temperatures are 55 heating flow and therefore 35 degrees on the return. But you need to have an expert to make sure there are no accidental or incidental consequences, that the temperature of the heating is going to be a lot lower, because at the moment most boilers, they pump out hot water around 75 or even 80 degrees. Bringing that down to 55 is going to make a huge difference to the temperature of the radiator. It's going to be a lot cooler, so therefore, is it large enough? And that's where this app comes into place. You can calculate very easily if the room leaks heat and how much kilowatts you need of radiator to keep that temperature up to 20 degrees. So you can do it on a piece of paper and a calculator if you want to, but your maths has got to be really, really good. There are videos to show you how it's done. I would suggest just simply download the app and put in the height of the room. Most houses will be 2.4 meters, so you put 2.5. For example, if the length of the room is maybe 3.25, you put 4 meter long. Make it just a little bit bigger. The width, if it's just over something, take it up to the next one. If it's just under 3 meters in length, take it to 3 meters. So we've got nice round figures. It's 4 meters long, 3 meters wide, 2.5 meters high. Put it in and then add the temperature of the boiler flows, whether it's an outside wall or a side wall or a window. All those very easy to input figures go into the app, and as you can see here, there's the answer. It tells you you need a radiator at least this size. And depending how far the boiler is from that radiator, you may have to make it a little bit larger. Another thing that you can do is, for example, if that lounge radiator is too small, maybe it will be just right for the dining room or the kitchen or maybe bedroom 1. So we can swap Peter for Paul, and then all we need to buy is a nice new one. With that comes one more thing: thermostatic radiator valves. If you're going to change the valves that you've got now, or you've just got these white cap ones, which are absolute rubbish, change them to balancing thermostatic valves, because they're the new ones. All the firms now are making them. You stick to that one. Here's the video that I made with Dan Foss, and it's absolutely brilliant. Balancing the system is the #1 first thing that you should do before anything else. Have all the radiators singing from roughly the same temperature and the same outputs. Then you can fine tune it with balancing TRVs, automatic bypasses, inhibitors, and so on, as I've covered with all the other videos. So download the app, make it easy for yourself, and then see if it's got the right size radiator in that room. As I said, start from the hall, then the lounge. That's the most important one. That's where the thermostat should be, and that's where you've got to concentrate on having the lowest bills. I hope this video is of interest to you. Thanks for watching and take care.
Today we're going to show you how to do the whole house heat loss calculation, and you'll see from the results tab we've already got plenty of results from one single house. We've done every single room in the whole house apart from bedroom 3. You can easily see on the results screen the heat losses for each of those rooms. At the moment it's showing in watts. If we go into the settings we can change that and we can show the results in BTUs per hour, and there you go, we've got it in BTUs per hour. But for today we're going to do everything in watts. So I'm going to do the heat loss calculation for bedroom 3. So it's 2.47 meters long and it's 1.98 meters wide and a standard 2.4 meters high. It's a bedroom. It's got one outside room, so I'll leave that outside wall. It's 220mm solid brick. Above the room is a pitched 100mm insulated roof, and below the room is a heated room. It's got one window which is a plastic double glazing, and the window is 0.86 meters wide by 0.98 meters high. And there we go. We're not going to enter in any flow or return temps, so we'll just press calculate there, and we can see we've got ventilation heat loss, fabric heat loss, but the total heat loss for the room is 487 watts. So I'm now going to save that to results. I press the button in the top corner, press save. We're going to call this Dove Lane Bedroom 3. Okay, and it's saved there, so you'll see it's appeared at the bottom, 487 watts. Now to do a whole house heat loss calculation, all we do is from the results screen, press the total button in the top corner, and we'll see we can now check individual rooms. So we're going to check every single room in the house and press the calculate button in the top corner, and we'll see we've got a total heat loss for the house of 8.5 kilowatts. And that's it, very simple.